Welcome everyone to our webinar titled Airborne Laser Scanning, Sensors, Mounting Options, and Productivity Improvements. My name is Michael Sitar and I'm the Division Director for RIEGL USA's Airborne Laser Scanning Systems. I'm not sure about you, but fall is really my favorite time of year. It symbolizes leaf senescence and the colorful changes in foliage as deciduous trees undergo chlorophyll degradation. This means winter is fast approaching in the northern latitudes. For airborne surveyors, it might mean the imminent survey season ahead, with leaf-off conditions for maximum ground detection. But for sensor manufacturers, it coincides with that other geospatial phenomenon known as intergeo, where immense trade show arenas are filled with new products and innovations, new features and capabilities, new tool sets that promise to make our lives easier, simpler, and hopefully more productive. This year, intergeo was a hybrid of in-person and online product demonstrations and announcements. This presentation will summarize a few of RIEGL's recent airborne sensor announcements at Intergeo 2021. Today, we'll discuss the performance increases of the popular VUX-IR lightweight LiDAR scanner, productivity improvements in sensor parameter planning using RiPROCESS, expanded versatility of RIEGL laser scanners on small aircraft via the new VQX wing pod, and finally, RIEGL VP helipods and installation examples. The success of these commercial off-the-shelf solutions has been significant. It is worth a quick look at what has been implemented on various platforms. Let's start with a quick review of the airborne laser product portfolio, beginning with our lower altitude sensors. The VUX-240 is an extremely popular instrument featuring a wide field of view of 75 degrees and a pulse repetition rate of 1.8 megahertz. With an operating altitude of up to 900 meters, it is the largest and most powerful of the small and lightweight instruments for both unmanned and manned ALS applications. The VQ-480 and the 580 Mark II, operating at 1550 nanometers and 1064 nanometers respectively, are intended for regional medium area mapping applications. Due to their identical form factor, they can be easily swapped, which is an advantage when it comes to system integration and certification of the VQ-480-580 platform on medium helicopter and aircraft installations. Both the VQ-780 Mark II and the VQ-1560 Mark II series are typically operated from manned aircraft. The highly desired matrix scan pattern of the VQ-780 Mark II series enables a grid-like point distribution and is extremely popular for applications that demand similar point spacing at the scan ends as that of nadir. The latest performance enhancements of the VQ-782 and 1560 Mark II wide area mapping sensors has resulted in the Mark II-S model variant. This new sensor model boasts extended range capability in excess of 4,800 meters on low reflective targets, a smaller beam footprint on ground for improved resolution, and in the case of the 1560 Mark II-S, an industry-leading 2-year manufacturer's warranty. Both instruments sample and store full waveform data, as well as perform online waveform processing if discrete data is preferred for commercial applications. One additional instrument in the lineup is the VUX-IR. This instrument has undergone a significant improvement and received the new name VUX-IR Edition 22. We'll discuss the following performance updates in detail. First and foremost, the form factor, weight, and interfaces remain unchanged to its predecessor. The major improvements are a significant increase of pulse repetition rate from 750 to 1500 kilohertz, as well as an increased maximum measurement range of up to 1000 meters, which gives a maximum operating altitude above ground about 640 meters or 2100 feet. Scan rate, accuracy, and precision remain unchanged to its predecessor. Also, the instrument features online waveform processing, the same electrical interfaces, and laser class 1 is maintained as well. So how do these improvements compare now to the previous version? Well, let's have a look at the chart showing measurement range over pulse repetition rate. As you know, the VUX-IR has 6 discrete PRR values to choose from, starting with 50 kilohertz up to 820 kilohertz. The new VUX-IR 22 edition now features the ability to choose any PRR integer value between 50 and now 1.5 megahertz, providing much greater operational flexibility for specific point density and AGL requirements, as well as much higher overall point density capability. The measurement range improved by a factor of slightly more than 1.2 at the low PRR rates and up to 1.44 at the higher measurement rates. The maximum pulse repetition rate improved by a factor of 1.8. Most importantly, compared to its predecessor, the new Edition 22 can operate at twice the pulse repetition rate for a given measurement range. So the next question then is, how do these improvements play out in terms of area coverage rates? This chart plots area coverage rate versus point density. At low point densities below about 12 points per square meter, the improvement is about a factor of 1.4. And at point densities above 12 points per square meter, the increase is even a factor of 1.8. If you ask how to determine these figures, I would refer you to one of our data sheets. But above all, I'd like to draw your attention once again to the RiParameter software. RiParameter is a sensor configuration application which can automatically or interactively determine optimum scanner configuration parameters for a number of different applications and use cases. This application forms the basis for optimizing sensor parameters based on RFP collection requirements, platform constraints, and sensor performance profiles. To improve workflow efficiency as well as provide more operational flexibility, RiParameter has been integrated into the RiAcquire workflow, where RiAcquire is the onboard sensor controller monitoring application for all RIEGL Airborne Laser Scanners. When defining a new scanner settings configuration, simply select New, and an additional pop-up window will open, allowing you to define a new sensor profile that is accessible via the RiParameter button. Doing so enables an instance of RiParameter where the user enters some meaningful values on desired point density or terrain variation, desired target properties, and sensor platform variables such as minimum maximum ground speed and operational altitudes above ground. Following this, the user simply pushes the play button to calculate the optimum scanner values that maximize area yield or area coverage rate based on the project and platform input parameters previously entered. And the new parameters can then be loaded directly back into the RiAcquire sensor controller software, such that these changes can be made in the air at any time, enabling minor parameter adjustments during flight if necessary. A persistent request from the industry has been the consideration of a sensor pod, designed specifically for small manned aircraft that have no existing sensor portal or camera hole. Equipping an aircraft with a laser scanning system can be complex and challenging, and this is particularly the case when a necessary sensor portal requires permanent modification to the airframe. This can be time-consuming and predictably expensive. Well, RIEGL has listened and now obliged by co-developing with Central European Aircraft Design a wing pod option for Cessna small aircraft, capable of supporting numerous LiDAR sensor and camera combinations. No permanent changes to the aircraft are required, enabling the rapid retrofit of portable sensor pods on plentiful and relatively cheap aircraft. The overall project objective was to capitalize on the ubiquitous presence of small Cessna aircraft that employ a top wing airframe design with wing strut support system. Relatively inexpensive and cheap to operate, these aircraft are already in use for low altitude visual inspection initiatives, such as oil and gas pipelines. The primary design requirements were as follows. Purpose designed to accommodate wing strut attachment to Cessna 172, 182, and 206 series aircraft. Compatible with the Meeker Airfilm's wing strut mount and DT1-1 dovetail disconnect system, which are already FAA approved. Be of lightweight construction to allow multiple sensor configurations, but not exceed max payload limits. Have a minimum frontal surface area to minimize drag on the airframe. Space to support the larger IMU types associated with high accuracy INS GNSS systems. Optional medium format cameras for a variety of application specific imaging requirements. Rapid installation and removal of the pod for transport and storage. And an easy certification process that enables quick field deployment. Pod frontal area of less than 1 foot square and a maximum payload of less than 30 kilograms were core objectives. And in summary, from a requirements perspective, the objective was to leverage the prolific availability of small aircraft as opportunities to retrofit this pod. From a sensor configuration perspective, the VUX is highly scalable to consider numerous sensor options. These include the RIEGL topo sensors such as the VUX-240, the VQ480 and 580 Mark II, and the RIEGL VQ840G bathy sensor. The INS GNSS solution that is offered, this pod can now support the Applanix AP60 high accuracy system. Up to 3 phase 1 IXM100 cameras are possible. It includes an external operator interface for sensor control, data storage, and a flight management system. And then finally, of course, the cabling that's required includes power, GPS, and a LAN cable. A look at how these payloads can be configured can be seen here. The first is the VQ480 580 Mark II with a phase 1 IXM 150 megapixel nadir ortho camera, a high accuracy INS GNSS system, and an onboard VUX-SYS computer system. This configuration would be best suited for small to mid-area mapping initiatives. An alternative configuration might be the RIEGL VQ840G topo bathy sensor with embedded small format camera and same high accuracy INS GNSS system as the configuration to the left. And finally, the VUX-240 with up to 3 100 megapixel oblique and nadir cameras generally associated with corridor applications. So let's look a little bit more closely at the detailed system components. The first is the wing strut mount, which is available from Meeker Aviation, and to this is attached a DT1 dovetail quick disconnect system. There's a rigid sensor frame, and this is imperative to maintain the IMU bore sight accuracy relative to the LiDAR and the camera lens perspective centers. Here we see an aft oblique camera, typically associated with a corridor collection scenario. There's a nadir camera for orthometric camera imagery collection. A vibration dampening mount, which in our case, we use the rigid wire isolators. Cam lock fasteners, allowing us to be able to quickly remove the shroud. A forward oblique camera. A carbon fiber reinforced polymer pod shroud. Here's a look at the inertial measurement unit, in this case the IMU 57, which is a part of the Applanix OEM AP60 solution. And in this configuration example, we have the VQ4 or 580 Mark II. And of course, we can add a number of other RIEGL LiDAR scanners in this area of the pod as well. A slightly different perspective, you can see the external connectors on the top of the pod where the power, the LAN, and the GPS cables would connect to. And then finally, at the back, what we see is a sensor computer and camera trigger box to be able to synchronize the cameras and provide a timestamp capability from the supporting POS solution. Now, certification of the VUX-1 is actively in progress. Our first tests are with our Cessna 206, with additional flight tests on the smaller platforms to be completed by the end of year. The next step then is EASA certification to be completed in the spring, followed by the application to the FAA. And this is likely to take another 4 to 6 months. In the meantime, clients are free to pursue their own local STC with the supplied EASA documentation with their local DAR once that's complete, once we have that documentation from EASA. And so this gives an option to be operational sooner if desired. And we fully expect to have first deliveries of the VUX-1 for the summer of 2022. And those would be fully configurable sensor pods with the delivered hardware components. Now, the following video gives a first impression of the easy mounting of the pod on the company's own Cessna 206. So the VQX wing pod really has its origins from the success of the RIEGL helipod configurations that were developed over the last 4 to 5 years. And based on the RIEGL VUX-SYS sensor system, the first solution release was the VP1 pod, carrying scanners of the RIEGL VUX-1 series. It included the Planix POS AV AP20 INS GNSS systems and up to 3 Sony Alpha 7R cameras at the time. The VP1 has since been adapted to carry the RIEGL VUX-240 with optionally integrated phase 1 high-resolution digital cameras. And our latest helipod solution, the VPX1, was introduced at Intergeo last year and is designed to carry the VUX-120 or VUX-240 and up to 3 high-resolution cameras with high-end Planix POS AV AP50 or 60 INS GNS systems. The VUX-SYS sensor systems with helipod are instantly deployable commercial off-the-shelf sensor solutions that are fully supported by RIEGL. And each platform consists of a carbon fiber shroud that surrounds an internal aluminum frame. The whole assembly is vibration dampened with spring isolators to minimize or eliminate vibration frequencies by being translated to the data collection system. These pods are designed to be below 20 kilograms in total payload weight. A single cable bundle is hard mounted to the pod with an external extension harness that can be quickly disconnected from the pod external connector panel. Hard mounts exist on the pods to support a GPS antenna, but generally speaking, it's recommended that these be installed somewhere on the helicopter top surface, and in particular the tail structures to reduce GPS shadowing and signal loss. And similar to the VQX wing pod, each helipod is compatible with the Meeker Airfilms DT1-1 dovetail quick disconnect system for ease of installation and platform compatibility. To enable the seamless control and monitoring all these sensors, an integration scheme is required, and for this purpose, RIEGL developed the flexible VUX-SYS computer integration system. And this consists of a suite of cameras, LiDAR sensor, the INS GNSS system we discussed, flight management system, and a compact computer unit. The computer unit, or CU, combines an OEM INS GNS board stack from a Planix with a camera trigger and synchronization unit and all the required processing electronics. The CU sources power from a power distribution box, or PDB, and routes communications via an Ethernet hub built into the PDB. Total power consumption is relatively low, as you can see in this chart, with peak current draw under 15 amps for a 3-camera system with computer, a high-power VUX-240, and the maximum accuracy AP60 GNSS INS system. So the following slideshow gives us an impression of the large number of installations made since 2015. There's almost 70 units that have been sold in various configurations. Supplemental type certificates have been issued worldwide for helicopter types that range from a Bell Jet Ranger to AS350, Hughes MD500, Eurocopter EC125s, 135s, just to name a few. And in conclusion, the new VUX-120, the new VUX-1LR Edition 22 provides superior range performance and point densities in response to requests for higher altitude capability. Integration of RiParameter into the RiAcquire acquisition software now enables on-the-fly parameter changes when environmental conditions vary. And the new wing pod provides a huge leap in platform compatibility options for small survey firms looking to deploy plentiful, cheap, single-engine Cessna aircraft without modification. And that's our presentation for today. If you have any questions, please populate those in the questions chat box, and I'd be pleased to answer them. And one of the questions I see is a second wing pod required for the installation onto a Cessna wing strut mount? And that's not the case. So in the video you saw two pods, but the STC and certification process is pursuing a single pod installation. A second counterweight or sensor pod is not required, just the one. Another question is, can the pod retrofit the 780 Mark II? And that is not possible. So the 782 is a little bit larger and is really designed for higher altitude, longer range performance. The pod and the sensor selection for that was done specifically to address the small to mid area mapping requirements at lower altitude and for relatively cheaper aircraft. And so the 780 Mark II is a little bit larger sensor than what I showed you earlier with the VQ480 580 Mark II, the VUX-240, and the VQ840G Tobo-Bathy sensors. And so that would generally be installed on a larger aircraft for higher altitude, wide area mapping applications. So if that's all the questions, I want to thank you again for attending. For more information on these and all 3D mapping solutions, please send an email to info@riegelusa.com or call us at 407-248-9927, or you can call me directly at 407-414-8669. And my email address is msitar@riegelusa.com. Have a great day, everyone, and thank you for joining in.